is Nadia Ursula. I'm from Standard J1 Senior High School, Jakarta. So, I will present about my research for storage simulation for renewable energy intermittency control with multiplexing and summing electrical energy as a form of sustainability in domestic scale electrical energy availability. So, along with time, the population continues to increase. That triggers an increase in demand of energy. The use of renewable energy contributes to climate change and the reduction of carbon emission. One of the UN programs, namely SDGs number 7, regarding clean and affordable energy source. Researchers got the idea to convert renewable energy into electrical energy. It's the same that this renewable energy has intermittency properties. Electrical energy is important for us. Sometimes, there are frequent power outages. Therefore, it is not necessary to have electrical energy resistance on a household domestic scale. To overcome the intermittencies, researchers designed a power storage simulation that forms electrical energy resilience. Based on this background, the research questions are: first, how to overcome renewable energy source intermittency with the power storage simulation, and then how does the configuration process more than one renewable energy source becomes flexible and sustainable electrical energy source. This is a power storage simulation block diagrams where using multi-source renewable energy, that is using more than one source of renewable energy. Then, these inputs are rectified and combined in a multiplexing and summing process that produce an output. Then, corrected by intermittency energy control, which will form a single power regulator unit. Then, stored in power storage. For the results, it has been explained previously that this simulation uses a multi-source renewable energy. So, there are solar panels, microhydro, thermoelectric, and etc. Its renewable energy source was directed in the rectifier unit while blocking the flow of electric current between renewable energy source so that the incoming energy does not occur backflow. Then, all renewable energy sources are combined in the multiplexing and summing energy process. The multiplexing process will choose the largest renewable energy source input, and the summing process will add renewable energy source that have equivalent energy levels. Output or VS was corrected by the intermittency energy control by autonomous to form a single unit power regulators, then stored in the power storage. An integrated power storage system was controlled by the power regulation system with a module called buck bus regulator, which controls the systems so that the quality of electrical energy output becomes stable and availability was guaranteed and or sustainable. This is a simulation graphic of power storage energy intermittency. The P symbol in the table shows the power generated by each renewable energy source installed in real time in the kilowatt unit. With this process of system, in innovation, it was assumed to design the average electrical energy output of 5 kW. The simulation can provide an illustration of the form of electrical energy resilience on a modern domestic household scale. If the electrical energy source system was applied there to PLN and renewable energy, then when there was a PLN electricity problems, energy users have reserve of an electrical energy source that comes from the resilience of electrical energy. Output or VS of the power regulator in the power storage system, which functions as a power system regulation and uninterruptible power when there is a shortage of energy supply from renewable energy source. Examples of load use with electrical parameters of 13.5 volt with a cumulated by amount of the average load of 250 ampere for 1 day, and then the power generated is 3,375 volts, and then the energy is 81 kilowatt hour per day. So with this simulation, if the systems that really distributes 1,000 times energy, then the load energy value, or EB, is 81 megawatt hour. So this is my research. I hope this simulation can provide an illustration of the form of electrical energy resilience on a domestic scale, such as a flexible and sustainable modern household. So thanks for watching.